We are extremely honored and excited to host Professor Hiroshi Ishiguro, on our event today, entitled Robots Have a Soul, Social Robots in Autism and Other Vulnerable Groups. Could you please mute to the attendees, Nico? I'm sorry about that. So Professor Hiroshi Ishiguro is currently a professor of the Department of Systems Innovation in the Graduate School of Engineering Science at Osaka University. He's also a distinguished professor of Osaka University since 2013 and a visiting director of Hiroshi Ishiguro Laboratories. His research interests include distributed sensor systems, interactive robotics, and android science. He has published more than 300 papers in major journals and conferences, such as Robotics Research and IEEE-PAMI. On the other hand, he has developed many humanoids and androids called Robovi, Repli, Geminoid, Telenoid, and Alphoid. These robots have been reported many times by major media, such as Discovery Channel, NHK, and BBC. He has also received the Best Humanoid Award 4 times in RoboCup, as well as other prizes like the Prize for Science and Technology by the Minister of Education, Culture, Sport, Science and Technology. And he was also awarded the Sheikh Mohammed bin Rashid Knowledge Award in Dubai in 2015. So we host Professor Ishiguro in our event today because of his research on robot deployment with vulnerable groups, such as elderly people, people with neurocognitive disorders, as well as socialization challenges, such as autistic people or young people suffering from the hikikomori syndrome. So this is a syndrome which is mainly found in Japan, where young adolescents and young people stay in isolation at home for at least 6 consecutive months, not interacting with people outside of the family. Of course, there have been greater periods that people have stayed inside their houses, mentioning even more than 7 or 8 years of enclosure. Hikikomori has been identified as an important risk factor for depression, suicide, obsessive-compulsive behavior, and addictive behavior. So today, we would like to explore, along with Professor Ishiguro, how a symbiotic society with robots could benefit vulnerable groups. So as you can see around you, we had the talented developer Kim Grip. Special thanks to Kim Grip for making this virtual world, which we own as a channel, and it's customized to the Japanese culture. The world was imagined after a Japanese temple. You can see the skybox, the real skybox, the background if you go around the walls. I would like also to guide you through the structure of today's event. So Professor Ishiguro will start with his presentation, which will be followed by questions by interview panelists. So we are 5. We've got an interview panel of 5 renowned academics and researchers who are going to set questions to Professor Ishiguro. And unfortunately, at this time, we're not going to receive any question from the audience due to time restrictions. So anyone who has any further questions can contact us by email, and you can find our contact details on the panel at the back of the world where you entered. And in terms of how we're going to go around this event today, all attendees will be muted throughout the event, including the panelists. Only Professor Ishiguro will be able to talk and will have his microphone on. And when we come to the section of the questions, I would like each interviewer to unmute himself and ask the question and then mute back. So I'd like to thank again everybody for being here today, and we can start with Professor Ishiguro.
Thank you. Thank you for the kind invitations. Can you hear me well? I hope you can hear me well, right?
Yes, we can.
We can.
Yes, we can.
Can you hear me? You guys?
Yes, Professor, we
Hello?
can hear you perfectly well. We can
Okay,
hear
okay,
you
okay.
perfectly well.
All right. Okay, so thank you for the invitation, and this is my great honor to be in the Japanese like virtual world. You know, this is my first experience, and it's quite quite interesting. And today I'm going to talk about the robot technology, but especially for the how we can use the robot technology for the autism kids, right? So we our group is a very big. The more than the 40 people are working together, and the some of them are working for the autism kids, and we are working with the hospital, autism hospitals, maybe more around the more than 5 years, right, together. So I'm going to show you the research results about that. But before that, you know, I'm gonna talk about the possibility of robot technologies. Right? So so anyway, so this is the my first slide. The title, sorry, something wrong. And my first slide, the title is studies on the interactive robots. My basic idea is to realize this human-robot symbiotic society um, in our future. You know, actually the especially in Japan, so we're gonna have a serious problem of the populations. Our population is going down to the half of current populations within 50 years. Therefore, we need to have more robots to help our daily life. So, my, you know, I'm uh, I'm trying to develop the human-robot symbiotic society for that kind of Japanese future societies. And as you can see here, the robot is supporting the human daily activities in various ways. So in order to realize this, the human-robot symbiotic societies, I have started my robot project under the project around in 2000. And so I have started with this mechanical looking robots, and then I have, you know, they developed these more the human-like robots and robot and the android. And the android means very human-like, and the very human-like robot that is difficult to distinguish from the real humans. So, and okay. So these robots, so I'm focusing on the human-like robots, and I believe a human-like robot can support our daily life in various ways. The question is, why do we need a humanoid robot or human-like robots? Well, the answer is the human has a brain that recognizes humans, and the ideal interface for human is a human. Right? Therefore, the information media devices such as talking rice cookers should be at least the partially human-like. And conversely, to understand humans, the very human-like robot androids are needed. Right. So this is the my basic ideas. And this is the reason why I'm focusing on the human-like robots. I'm trying to, you know, I'm trying to develop the human-like robot, but at the same time, so I'm trying to understand the human itself by using a robot, right? And of course, so we can consider the applications, the rehabilitation of communication through the dialogue, especially for the autism kids. Okay, So we are using a robot to provide a communication training for the children with autism spectrum disorders and like this. Okay, so and here we are. There are two cases. One is the human operator is operating this robot and talking with autism kids, and the another case is that we can use the fully autonomous robots, conversational robots, for the simple, their conversations. Okay, we are developing both types of robots, and the by introducing a robot to the medical examinations at developmental clinics, uh, and we can classify the symptoms of children with SD and continuously verify the effects of exposures, right? Therefore building the relationships with humans, right? This is a very important. So robot is a very important tools for understanding the autism spectrum disorders that we think. And so this picture shows the another example of how we can use a robot. So and actually he is a medical doctor, but please consider that this medical doctor is an autism child, right? And the another person here, that this person is the controlling the robot, right? And the talking with the autism child, right? And the interesting thing is that even if the operator is just next of autism child, or he or she, they she doesn't care about the operators, right? He or she just focus on the conversation with a robot, right? And they can enjoy the conversation with the robot very much, right? Of course, the autism child knows the next person is operating the robot, but still, they like to have a conversation with the robot. So anyway, I think the robot is a very, very important communication tool for the autism kids, autism child, because as you know that autism child, they don't like to talk with humans, but they prefer to talk with the robots. Therefore, that we can use a robot in various ways for treating the autism children. Right? So, what kind of a technology do we have, for realizing these autonomous and teleoperated robots for the autism kids? I'm going to talk about some details about our technologies after this. Okay. Sorry, before talking about the details, this is a kind of a typical scenes how we can use the robot uh, in a conversation with the autism child, right? So, and usually the nurse or doctors are they're operating on this robot, and the robot is talking with the autism child like this. Okay. So let me talk about the some important technologies in robotics. In a previous robotics, we have focused on the development of these fundamental the things and mechanics and manipulators and sensors, and thanks to the deep learning, so we could have human level image understanding functions and the voice recognition functions. But however, the AI realized by deep learning is a very much different from the human intelligence. After this, we need to carefully study about the human-like intelligence, you know, based on the technologies given by deep learning, and we need to study about the embodiment. embodiment is the main importance of a body property of the robot, right? So robots need to have their own experience by using the bodies, right? So that is the embodiment. And the multimodal integration. So we have the good technology for the image understanding and the voice recognitions. But what we have to do after this, we need to integrate multiple modalities, like voice and the visions and the tactile sensations, and and the robots need to gather the information from the external world. So that is the multimodal integrations. And we expect to have a more autonomous robots, and androids. So how we can realize that? Fully autonomous robots need to have intention, desires, right? We programmers need to give desire to the robot, and then the robot can be autonomous, fully autonomous. And if we can give an intention desire to the robot, we may feel the consciousness of the robot through the interactions, and then we may have more better the social relationships with the robots. So these topics are going to be a very important topics for the next decade. So these are closely related to the meta-level cognitive function of humans and robots, right? So this is the new challenge in robotics. And if a robot become a more human-like, and we can use the robot um, for treating the autism kids, for making the conversational partners of the autism kids. So I think that is a very important possibility of robotics for the autism kids. Okay. So this is the roadmap of robot development in my laboratories. Now they're focusing on the language teacher robots and order taking robots at restaurants, and some the conversational robots for the elderly, right? And after this, we're gonna implement the more human-like functions onto the robot, and I hope we hope to reach to the companion robots, which has the many human-like functions for interacting with the their children and some, well, the many kind of people. So these are example of the conversational robot. These are almost practical, and actually, there are several companies um, who are selling the language teacher robots, and some companies are using the robot at restaurants. And well, some, and we are also using the Android robots, the very human-like robot, as a receptionist. So, and this is a relation between the science and robot development, and intelligence and embodiment and the multimodal integration. These are fundamentals. And if we can implement intention desire, the robot will be very human-like, and we may realize the companion robots that can pass the multimodal Turing test. So let me briefly introduce the what is the multimodal Turing test. So probably you guys the Turing test proposed by Alan Turing. So Turing test is comparing the computers and computer intelligence and human intelligence. But here we are comparing the robot intelligence and the and human intelligence. So here interlocutor is talking with the robot. Okay, and in this case, the robot is still operated by human operators. But if we cannot distinguish the mm, uh, the robot that is operated by computers, so this case is a computer is controlling a robot. If we cannot distinguish which is which, so if it is operated by human operators or if it is controlled by computers. So in this case, we recognize the robot can pass the multimodal Turing test. So this is our scientific goal, right? And scientific and engineering goals. Okay, and so by then I'm going to talk about some fundamental issues. Okay, so let me go back to here. Right. So important things is deeply study about these scientific the issues, right? And first, I'm and one of the fundamental issues I want to talk about the feeling of a presence. So that is called the sonzaikan in Japanese. So this the issue is closely related to the meta-level functions of multimodal integrations. Okay. So if we use the very human-like robot, then we can deeply understand the meta-level cognitive function of humans. So one of the important function is the feeling of a presence, the sonzaikan. Okay, I have developed the teleoperated Android first in my project. So and then I have realized this uh, uh, the my copies, right? So this is the my Android myself, and here I'm operating this Android by um, by using the through the internet by using a computers. And here I'm just talking, right? And then I'm watching the monitors and talking, and then the computer analyzes my voice and generating a lip movement and head movement of this Android. But anyway, this operation is a very simple. I'm just talking, and then I can have a very natural human-like conversation with the visitors. Right? And I'm using this robot for the meetings. And of course, we can use this Android for the conversation with the autism kids. But we have compared which is better, more cute robot-like robot or very human-like robot, which is better for the autism kids. Our the result was the usually the autism kids likes to talk with the robot-like robot, right? But and well, if the so if we compare the young autism kids and a little bit more senior autism kids, right? The senior autism kids can accept the Android. So that means it's quite important to have to prepare the several types of the robots, from the very cute small robot to the very human-like robot, right? So by switching the robot for the in the conversation with autism kids, so the you know we can have a better training, conversational training for the autism kids, right? So autism kids can start with a very mechanical looking simple robot, and and the autism kids can talk with can have a conversation with a more human-like robot. Finally, autism kids can have a conversation with the humans. So I think we can take that kind of approach for the conversational training of autism kids, I think. So anyway, so and here what I want to say is the Android, the teleoperated Android can represent the my presence. Okay, so and I can work with the this Android. I'm calling this Android Geminoid in a distant place, right? So this is a very convenient, especially in the under COVID-19 situations, right? And when I have developed this teleoperated Android, I have found the very important ideas. That is recognition based on the observations. If that android, the robot, is very similar to myself, usually the observer, they carefully observe each modalities, the appearance and the voice and the gestures. So if one of the modality is not human-like, and if for example, the gesture is quite jerky, right? And then this observer they considers probably this robot is sick, and it's so uncanny. So that is uncanny valley, right? So if a robot is a human-like, the robot or android need to have the human likeness for the all modalities, appearance and the movement and the voice and everything. Right? But on the other hand, if we use the very simplified design appearance for the robot, in this case, we are using this simplified design for the Android, right? So the robot looks like a humans, but we cannot tell the age and the genders, right? And this is quite neutral the appearance. So in this case, the observers, the human observers, use the imaginations for the interactions. Okay, so and actually, this very simplified robot can activate users' imaginations. So she is the very senior. She is not, the dementias, but she doesn't like to talk with humans, right? And usually she never talk with the human, right? Medical, including a medical doctor and families. But when we give, uh, give this teleoperated robot to her, and she could talk with this robot very much, right? And I think that this picture is much better to understand, right? So we are running this kind of experiment in many countries, in Japan, and this is from Denmark, and we are also running the experiment in Germany and Italy, many countries. So what we are doing with this simplified teleoperated robot, so we supporting the communication of dementia people and the elderlies in the elderly care houses, right? Usually the elderlies, dementia people, they don't like to talk to humans, but therefore it's quite difficult to have proper diagnosis, through the conversations. But if we give this simplified teleoperated robot to the elderlies, almost all elderlies, well, they can they can be relaxed, and they can they can talk with this robot very much. The same things happens for the autism kids, right? I somehow the elderlies are similar to the children, right? And they probably they are feeling a kind of a pressure to talk with the humans, right? But and uh, in a conversation with simplified robots, and they can use their own imaginations in the conversations, and they don't feel the pressures, right? Actually, this robot works very well for the elderlies, right? And um, so look at the robot again. So this robot is called a Telenoid. This Telenoid is very much simplified comparing with my Android. Okay, let me go back to my Android. This is my Android. It's so complicated. This is a very simple, right? And the question is, what is I think, okay, so now its slide is coming. So what is the minimal measure to transfer the human presence? So my answer is this, right? Um, so this is the minimal condition to feel the human presence. So minimal condition means if the robot has two modalities, right? In this case, the two modality means voice and the tactile sensations. Then the people can feel the human presence very much, right? So this is the it's huggable pillows, um, but we are using smartphones here, right? So, these guys are holding the huggable pillows and talking through the smartphones, through the mobile phones. Okay, very simple. Right? This is not robot anymore. This is a very simplified the huggable pillow, which has the two modalities, tactile sensations and the voice. But this one works very well, right? We have compared the two conditions, right? Actually, we call this huggable pillow the huggies, and we have compared the conversation with normal mobile phones and the conversations with the huggy, and we have um, tested the hormones in the blood and salivas, right? So this is the result. Actually, we can reduce the level of the cortisol by using the Hagibis. Okay, so the cortisol is a stress hormone. So, if we can reduce the cortisol levels, that means um, the um, the people the users are relaxing them very much. Right, this is a very strong the effect of this. The Agabru pillows and this very simplified robot. So I think that this is the experiment from the elderlies, but probably we can say the similar things to the autism kids. Okay. Anyway, so this is my assumptions. Uh, well, the huggable pillow, the Hugby, that has the two modalities that two modalities of voice and the tactile sensations, but we can consider the different combinations. The appearance and tactile sensation, the smell and tactile sensations. Anyway, so two modalities are enough for feeling the human presence. But if we give too much modalities like very human like Android, the um, the uh, the strength of feeling of presence is going down because of uncanny bodies. Right? This is my hypothesis, but it's quite difficult to verify this hypothesis. But I think this hypothesis can be a very important the design policies uh, for the robots that can be used for the autism and the dementia people, dementia elderly. And this is another example, right? And this is the first grade, the children in elementary school. So they are so, they are a little bit nervous, and in the front of the teachers, these guys are carefully listening the teachers talk, but these guys are not, they are talking the teachers talk. Then we have delivered heartbeats to everybody's and transmit the teacher's voice through the heartbeats. So and then everybody could focus on the teacher's talk, right? And probably they were feeling the the teacher's presence, um, through the heartbeat, right? The heartbeat is a very strong, right? Can have a very strong effect for relaxing the children. Okay, and we are running this kind of experiments in many elementary schools and some schools for uh, uh, um, school for uh, not just for the autism kids, but and, and, the, the kids which has some mental problems. So actually, the, this habit it works very well. So anyway, in order to transmit, in order to give a feeling of a presence, sonzaikan, of course, we can use the very human-like robots, Android, but we can make it more simplified, and then the simplified robot can be accepted by everybody, including the autism kids and elderly. Right? So that is our findings about the feeling of some icons. Then let me talk about the conversations, right? And what is a conversation? Conversation is, you know, um, um, so we consider like this. The conversation is to share the story, right? So, usually robotics researchers, they are focusing on the conversation, one by one conversation, the conversations between one robot and the human interlocutors. But the one by one conversation is not the real conversation, I think. I I think the more realistic conversation start and with the three people, three humans and robots, more than three, right? Um, so and if well, for the one by one conversations, and then, for example, the robot is talking with the humans. In such case, the human can adapt to the robot, or robot can adapt to the humans, and they may not use the language carefully, right? But if we have the three people, right, in order to understand the other two people's the conversations, the third persons need to understand the language. Therefore, we can have um, more realistic conversation. Uh, uh, so, and so if we consider, right, the conversation among the three people, so we can have this kind of strategies. So what is the strategies? Then this is very interesting. So, if what this guys, the well, if a robot need to talk with the humans alone, right? If we don't use the two robots. If we use just one robot, the robot need to perfectly understand the human's utterance, right? But if a robot, we use two robots, okay? So these robots does not need to understand human utterance, okay? Think about this kind of a conversation patterns. Robot ask a question to the humans. Before that, the robot asked the question to the robot, and what is your favorite food? And this robot answered to that question. My favorite food is sukiyaki. Okay. And then the robot asked the same question to the humans. What is your favorite food? And the humans answered. Okay. So, for example, my favorite food is a tempura, right? And then this robot always says, "I see." Okay. Then the robot can ignore this human utterance. So the why but this robot, they can continue the conversation the conversations with the humans, right? Even if this robot does not understand the human utterance, right? By taking this kind of conversational strategy, the robot can keep the can continue the conversation. So this is the meaning to use the two robots, or a meaning to use to have a conversation with three people, right? Once the robot establish the stories with the another robot, okay, and then the robot can involve the human interlocutor to the conversations by just asking the same questions, right? So robot does not need to answer to the questions, okay? That does not need to reply, and I mean, it does not need to understand the human utterance. Always, robot can just say, "I see," right? So this is the very important finding, for having the very stable robot, the conversational functions of the robot. Okay. Anyway, I'm going to show the video later. Right. So if we use that kind of strategy for the human-robot conversations, if we use the two robots, okay, so the robot can continue the conversation with the elderly and autism kids very naturally, right? Usually, the elderly's utterance is not so clear. Therefore, the robot is difficult to understand the elderly's utterance. In such case, the robot is going to talk with the another robot, and then robot is going to wait for the elderly's response, right? So elderly, they can join to the conversations anytime. So it's quite a little bit difficult to clearly explain without the video, but what I want to say, if we use the two robots, we can have a very stable, fully autonomous conversational functions, and the robot can provide the conversational services to the elderly and maybe the autism kids. So I'm going to show the videos later. Okay. So and then let me show you the another example. How the two robots, the conversations with the two robots works, especially for the autism kids. So interaction with multiple robots in nonverbal communications under the weak pressure. So if we use the two robots, this actually this is autism kids. Autism kids, one doesn't feel the strong pressure, right? So with a multiple robot, he or she can join the conversation without having to keep talking, right? Even if he or she doesn't talk anything, two robots can talk to each other and can keep they continue the conversation, right? And the robot can continue the dialogue even if the one person they doesn't reply, right? So, and suppose the robot is asking a question to the autism kids, and even if he or she couldn't reply to the robot, and another robot can reply to the robot, right? So by using two robots, therefore the conversation with the autism kids, and autism kids can easily talk with these robots. And this is the merit, to use the two robots conversations for the elderly. The autism kids. And the dialogue with the two robots is easier to imagine the mind of a robot than one, right? So, and again, so, um, and we have tested which is better, one-by-one conversation or two-by-one conversations. In this case, you know, that this guy is talking with one robot and the other, and here, well, the right figure, you know, the person is talking with the two robots. So if we use the two robots, the subject feel that the robot had a heart. The feel likes that the robot have a heart, right? And then you know the you know if the person talk with the two robots, and the person feels that you know the person can the person is able to communicate with the robot, right? So two robots is always better than the one robot in this experiment. And I think you know this is also the important for the autism kids, right? So autism, probably the autism the kids can feel the heart through the two robots conversations, and the autism kids can have some they can easily have communications with the two robots, yeah, more than the one robot. So I think I have spent almost the 40 minutes, I guess. And when you know, when you fix time to express things, and then you know, I want to show you the most advanced the robot technologies. So, and how we can develop the fully autonomous conversational Android. We have implemented the, our purpose was to implement the intention desire to the Android very human-like robot. And the intention desires looks like this. The desires decide the intention decide the execution order of behaviors and utterance, right? This is a very simplified the architectures, but actually, you know, our robot consists of a huge, huge amount of computer programming. And this is the desires we have implemented onto the Android. And as a personal desires, we have implemented the desires for building the relationships with others. And as the social desires, we have implemented the desire for qualifying the relationships with others to the Android. And you know, and we have developed this very, very human-like Android. And I hope these technologies can help to realize the autonomous conversational partners for the autism kids in the near futures, right? And you know, the autism kids can have the conversation trainings with the robots. So that is a possibility. Okay? So anyway, let me show you the videos on these robots. Okay, before showing that, you know, my final goal, let me talk about my final goal, right? So my final goal is to realize the human-robot symbiotic societies in the near futures. Okay. Okay, going back. Okay, just a moment. Sorry. Sorry. And This is robot.
旅行の話について聞きたいんだけど、飯尾さんは
Two
旅
robots.
行
Two
は
robots are
好き？
working with
はい、大好きです
the elders, and this is the fully autonomous
そっか。
conversational robots, and this is
僕
very
は
stable.
旅行が好きなんだ。
And then I'm going to show you the most the advanced Android here. So this robot Android can talk with interlocutors, the file for 10 minutes. Of course, we need to limit the situation and the purpose, right? But I think this is the most human-like Android in the world. Okay, thank you for your attention. Sorry for taking much time, and I want to accept the question.
Thank you, Professor Ishiguro. I think everybody in this event must be quite impressed by your work on robots and specifically androids. I mean, your androids must be the most human-like robots in the world. I mean, we can tell everything is so human-like and realistic. So thank you very much. And now we will start our interview panel with our questions with Dr. Parskevitria Dafilopoulou. She's a lecturer in intellectual and developmental disability at Tizard Center, University of Kent in UK. She's also the co-founder of Autism VR, and her research and consultancy focuses on health, psychological interventions, and autism assessment. She's also a member of the Tizard Ethics Committee and has been working with people with intellectual disabilities since 2006. Vivi, over to you.
Thank you, Anna. Thank you so much, Professor Ishiguro, for today's talk. Such an interesting presentation. Android's really opening up a new world with so many potentials. And I'm going to tell you now that I have been receiving messages from people commenting during your presentation, commenting on how much your work has influenced them, especially in the arts. So what a great impact you have had. So I just wanted you to know that before moving on to my questions.
So sorry, I cannot hear you.
Can you hear me now?
Yeah. Go ahead.
Yes, I was just saying how.
Okay, go ahead, please.
Can you hear me now?
Yes.
Lovely. I was just saying that I have been receiving messages during your presentation from people and commenting on how much your work has influenced them and how great of an impact you have had in the arts world. So I just wanted to communicate that to you before I would move on to my question. What I was going to ask you today, so I've been working a lot with autistic individuals. So this is my area of interest. This is my area of world. And I was, my background is psychology. So I'm a clinical psychologist of intellectual and developmental disabilities. And I was thinking about the implications your work has to practice. So when we're looking at social robots and autism, and I can see clear connections there with anxiety management, that study that you did, the cortical levels, the stress, so the use of the Hagri and I can see how that would work with autism, and I know that there's already a bit of research on that, but also I can see how there might be connections between robot intention and use perhaps instead of, because you talked about conversations, thinking about social stories. So the social stories that, just in the case that the audience is not familiar with social stories, these are used to help autistic individuals with interpersonal communication, interaction, and social situations. So, so basically, I would like you to comment on the implications that your work has to practice on the autistic population.
So I think, well, your question is what the implications of social robots, right?
Yes.
To the
Yes, to
practice with,
autism.
yeah, autism, right? So, yeah, I think, well, the robot is a kind of, well, so this is my feeling. So robot it can be a kind of a new kind of a humans. That is in between the, well, how can I say the the autism kids and maybe including the ordinary peoples. We want to have little bit different types of conversational partners. Sometimes we feel the very strong pressure to to talk with normal people, but robot is different. Robots never give us the strong pressure in the conversations, especially the some simplified robots. So I think um, the social robot is going to be a kind of a variety of humanities, right? We have so many different types of people in this world, right? Therefore, that we need to prepare the so many different types of conversational medias, conversational partners. So robot can be one of the new types of conversational partners for the humans. So I'm not sure, that I could answer to your question properly, but this is my feeling.
Yes, yes,
Can you hear me?
certainly. And I'm thinking of probably how to take this even further with
Mm.
the autistic population, the autistic individuals. Those interactions with the robots, that they're so much like humans, then training them and giving those interactions, those first interactions, as training in order to be able, so like we had an event, for example, talking about interviews, job interviews. So how good would it be if someone would be able to actually use the robot for an interview, so they can get that training in order then to go for a real job interview and be able to respond to those questions. So yes, I can definitely see very much potential there.
Mm. Yeah,
Gonna,
especially for the job interview is a very important application for the robots. So job interviews, the people, usually the people hesitate to talk to the human interviewers about the personal things. But usually the people we don't hesitate to talk with a robot about the personal things. We did the experiment before, right? And the robot is much better, right? So
yeah,
that is the possibility of the robot.
yeah, certainly. Thank you ever so much.
Yeah.
We'll pass on to the next. Next.
Thank you, Professor Ishiguro. So the second question comes from Dr. Nigel Newbert. Dr. Nigel Newbert is a senior lecturer and researcher in digital education at the University of the West of England in Bristol. Dr. Newbert has been well known in UK and the rest of Europe for his innovative research in virtual reality with autistic young people. His most recent research explores the use of robots with autistic students in special school settings. Nigel, over to you.
Thanks, Anna. Thanks. I assume you can hear me okay, yeah?
Yeah.
Brilliant. Okay, well, thank you all. Just to echo the comments there, that was a fascinating and very interesting talk you've just given us, Professor. Thank you very much. And so much in there, and I saw you had to skip some slides. So obviously, your body of work is immense. And so thank you for sharing some of that with us. So as Anna said, I'm very interested in how technology can support autistic groups in a range of ways. And as the previous question was around job interviews, and sort of those sort of aspects are very central. But I want to ask a sort of a two-pronged question, if that's okay. And part of it comes from a PhD researcher who works in the Tizard Centre at the University of Kent, who asks, do you think that autistic people who do not have an interest in robots or technology would enjoy and benefit from this type of technology? So that's part one of my question. And part two is the work that I do is very much focused around working with autistic communities to help co-design what robots might do with them based on their inputs. And I just wondered if you could talk to a bit about that in terms of your own research. Do you involve the voices of your participants and the people you're working with in helping to design the type of robots that you design? So two-pronged. First of all, do you think people who are maybe not interested in this technology can still benefit from it? And second of all, how do you involve the voices or co-design with your participant groups?
I think that this how the I think this is a very important challenge. It's quite important to involve the autism, the kids and the peoples in the design of robots. So I think that is a very important, right? We are, we are running experiment in the autism hospital, and always, we are talking with the people, and then we are getting the feedback from the people, right? So, but we, honestly speaking, we don't know yet how we can design the more better the robots, in a collaboration with autism people. I think this is a kind of step-by-step approach. But one of the important, our finding was actually, if we use a use the conversational robot for the autism people, we can classify the autism the carefully, right? So actually, the autism is so complicated. Probably you are professional, right? And and sometimes we do not understand the a little bit difficult to find the policy of treatment. So and through the by analyzing the conversation with a robot, we can classify the autism, the peoples, and then that we can find some treatment policies for the autism, the peoples. So that we can use the robot in that way. So that means, I think, no, it's kind of a co-designing of the robot systems for improving the autism people's situations. So that is our approach.
Thank you very much. I really appreciate that comment. And it's very reassuring and pleasing, certainly with the work we're doing, to hear how you sort of echo the idea that co-designing and listening to the groups we're working with is very important. And I think the insights that we've found by taking a robot into a school and asking the young people how they would like to interact and engage with the robot, but also where they would like to interact and engage with the robot, has been quite revealing, actually. And that will help guide the next part of our research in that setting. And I also wondered, just a bit of a brief follow-up, do you feel that the more we co-design and the more we work with these individuals, maybe the better the uptake of the technologies might be? And that sort of speaks a bit to the previous question around the sort of research to practice gap, which we know is quite large in this space. Do you feel that if we work more closely with our participant groups and our target users, that we may see better uptake and better sort of, this isn't quite mainstream yet, is it? And it'd be, do you feel that that would help bridge that gap and then help get these tools to the people who can benefit from them?
And I couldn't clearly catch your point.
It was really just to reinforce that I wondered if you felt that the more we work with autistic groups, in this case, for example, co-designing with them, do you feel that that will
Mhm.
help bridge that research to practice gap where we may see the uptake, a greater uptake of robots, for example, with
Yeah,
autistic
yeah, I
people?
think so. I think so. But the autism is so complicated. And it is not so simple, right? Therefore, it's quite important to work together, right? So we need to find the new research framework, by collaborating with autism people and the robotics researchers, right? So well, that is my feeling. So this is totally different from the previous simple the medical treatment. So the well how I don't know, so it's a little bit difficult to clearly explain that, but I really think it's quite important for working together.
Fantastic. That's fantastic. I really appreciate that response. And like I
Yeah.
say, it's really reassuring to see how you're building that into your own work and hopefully for the benefit of the people we're working with. So thank you so much. I love the talk. Thanks again. I'll hand back to Anna.
Yeah, thank you.
Thank you, Prof. The next question comes from Dr. Jim Ang. He is a senior lecturer in multimedia and digital systems in the School of Computing, University of Kent. And he has 15 years of experience designing digital technology for social good in domains such as education and healthcare. His research focuses on implementing this technology to people suffering from mental health problems. So because of some technical issues that Dr. Ang faces, I will ask the question on behalf of him. So in his field of digital health, especially in mental health, we are starting to see more research on using chatbots to support people with mental health problems. How do you think physical humanoid robots could transform mental health service around the world?
Well, I think they both are important. I think, but the human brain, we have. Our brain is tuned for the 3D environment in the physical world. Therefore, we can naturally use the multiple modality for the conversations in the physical for the physical robot. So so that is much better than the chatbot or simplify the virtual the agent, right? And I really think the physical robot that works better than the chatbot or some other two-dimensional the computer graphics robot. We have tested it. We have tested many times, and we have compared which is better, right? So and then our guess is and especially for the treatment of autism kids, maybe the multimodal interactions in the conversation is quite important. So that is our feeling, our findings, I think.
Thank you very much. And on behalf of Dr. Ang, Professor Ishiguro. So the next question comes from Dr. Alexandra Kovacci. She's a researcher in the field of virtual reality, and she's currently a lecturer in digital arts and technology at the University of Kent. Her research interests are centered around the transformative power of virtual reality from training to social scenarios. And her research activities lie at the confluence of virtual reality, multisensory media, human-computer interaction, and psychology. Hand over to you, Alex.
Thank you, Anna, and thank you, Professor Ishiguro, for your presentation. It was fascinating. So I will try to keep it short because I'm not sure how much time we still have, or if you have any other questions. So my question is around how can we create an avatar system that can transport human presence to a remote location instantly? So let's say if we envisage a scenario where a doctor in Japan could export their skill set virtually to respond to, I don't know, a natural disaster around the globe, how do you think we could break through these physical limitations and expand the capacity of humankind itself. How
Sorry, I couldn't clearly hear your voice, and just repeat the point of your question.
Okay, so my question is about how can
Voice is gone.
There is, I think Alex is having some audio issue.
Could you repeat your the questions?
Okay, I am back. Do you hear?
Okay. Okay.
I was yesterday with Anna and I disconnected and I said, I hope that I will not disconnect during asking my question, and exactly this happened. So my question is, how can we create an avatar system that can transport human presence to a remote location instantly? So I'm thinking here about avatars that are operated by other humans. How could we convey basically a sense of presence for both the operator and the recipient of these interactions?
Okay, so how we so the question is how well we can adapt to the Android, how we can accept the robot as our own bodies, right?
Yes,
no.
and
I guess your question is, yeah.
Thinking about scenarios where we can basically export our presence, so we can be, let's say, in New York, but in the same time have a robot that operates for us somewhere in Japan. So let's imagine this kind of situation. So remote working or just remote social interaction. So how can we actually convey a sense of presence for both me, the operator of the robot, and the person who is interacting with the robot?
Right, actually, we did the very interesting experiment. So once we control the teleoperated the Android and robots, so our brain can accept the Android body as our own body, right? So so the teleoperated robot or Android is not just the robot; it's going to be a part of our bodies. So, and especially if we use the brain-machine interface, right, we can easily accept the Android body as our own body, right? And that we can have a very realistic feeling to be there, right? So that is our finding. So, and of course, we need to improve the interface more. But the near futures, I think that we can exist anywhere by using this Android teleoperated Android or robot technology. Probably, I think I could answer to your question.
Okay, thank you.
Yeah.
Thank you, Alexa and Professor Ishiguro. I have a final question, and if we have time, we can ask another one. So this comes from me, Professor Ishiguro. I'm a PhD student in computing at the University of Kent. So my question is, much of your research focuses on the physical appearance of robots. Could you explain why you think that interaction with these physically embodied entities has greater results in vulnerable groups when it comes to socialization and companionship compared to 2D virtual beings?
Yeah. Okay. As I explained already, the physical presence is very important, because our brain is designed for for adapting to the physical the space, right? And we have compared the many times in physical and the physical robot and 2D computer graphics agent. Always physical robot is better, right? And however, right, so I think it depends on the purpose and the situations, right? So sometimes, of course, that we can use the virtual agent. So for example, everybody using a smartphones. If the virtual agent appears on the smartphones, so we can talk anytime with the virtual agent, right? So if the person want to have that kind of conversational partners, the virtual agent, it works very well. But if we hope to have a more natural conversations, right? So the physical robot is better, and actually we can touch to the physical robot. We can feel the very strong the presence of the physical robot, and we can have a more strong feeling of the conversations and the presence through the from the physical robots. Right? The people ask the similar question to me always, but the important things is we should choose the best robot according to the situation and purpose. I think I could answer.
Thank you very much, Professor Ishiguro. Yes, thank you very much. Thank you. And I think we have 2 minutes for Vivi's question.
Yes, thank you. So actually, this is a question coming from Krisha. She's an autistic PhD student in the TESOT Centre at the University of Kent, where I am at. And very well, she's been asking about the double problem. I'm not sure if you're aware of this, so I'm going to explain it briefly. So the double empathy problem is that it's saying it's not that empathy,
Sorry.
but
You're breaking up quite a bit there, Vivi. You're breaking up quite a bit, to be honest. Yeah, so
I'm so sorry. Okay.
Maybe keep it if you can. Yeah, I don't know if it's best to keep it brief in terms of, because we're missing out keywords every so often that you're when you're explaining.
I'm trying
Could you
to
please
explain,
repeat the question, Vivi? Yes. Okay.
Sure. So I was trying to explain about the double empathy problem. Is that it's not that autistic people lack empathy, but their experiences, it's actually making it harder for non-autistic people to understand the autistic individuals and vice versa. So the question is, what are your thoughts on this? Do you think that robots can help non-autistic people understand the autistic individuals' lived experiences?
I see. That is a very interesting question, and well, I don't know how we can use a robot for that kind of a purpose yet, but well, I see. Well, that is a
Tough
very
one.
important
Sorry.
thing. But you usually we have maybe in my case, sometimes I think and I can understand the mind of autism, the persons. For example, I don't. It's not, sometimes I have a strong pressure to talk with the humans, but I don't feel the strong pressure to talk with a robot, right? Therefore, everybody has the kind of the features of autism, right? Maybe the weak features of autism. Therefore, through the if by sharing the similar experiment through the robots, right? The autism, the people and autism kids and normal the people they can share, right? The similar ideas, right? So robot is the much easy to talk, right? And then the ordinary people can understand the autism, the people's mind. So we can use the robot in that ways. But probably I have to consider the more positive, strong way to share the autism, the people's life, and I mean, well, the normal people, we need to help to understand the autism people about the autism people by using a robot. So we need to think about more than that. So this is my homework.
Lovely. That it's great. It's great to open new horizons really, and to open up new ways to see things. So that's something that we could really talk about and to see how you could perhaps explore a bit further. Thank you so much. Thank you.
Welcome. Thank you for the very interesting question.
Thank you, Professor Ishiguro, first of all, for accepting to give the talk and accept questions from all the panelists. Special thanks to you. And also special thanks to all the panelists that supported that event. I would also like to thank Kim Grip for the virtual world he specially made for us, Jason Wong for filming the event, and I will upload the video link so you can all have a look, and Nico, our moderator of the event. So without all of whom this event, of course, wouldn't be possible. So I'd like to thank all of you, and hopefully we'll meet again in our future events. Thank you very much.
Anna, could I just say thanks to you as well for putting this amazing event together? You know, this is a very high-profile event, and you've brought it together really well and facilitated this for all of our benefits. So thank you very much, Anna.
Thank you, Nigel. It's the team that makes the event that good. It's in the collaboration, among all of us. So it's a team event. Thank you very much. Thank you. Vivi, would you like to say something?
Yeah.
Could you please turn on your microphone? Yeah.
I thought it was. I'm just thinking that perhaps we might need to have another event to explore all the slides that we skipped. So watch this space.
I think Professor Ishiguro is now an expert in presenting this platform. So I mean, yeah. We also thank him about this. So thank you, everybody.
Thank you.
Yeah, thank you, everybody. Thank you for this very interesting the invitation to this interesting conference. Thank you so much.
Thank you. So if you feel like you would like to explore the world, I mean, you can stay a little bit longer. So we'll be seeing each other in our next event in July, and we will keep you all updated. Thank you very much. Thank you.
Yeah, thank you.
Thank you.
Thank you so much.
Thank you.
Thank you very much, Professor. Thank you very much.
Thank you so much.
Thank you. I've been watching.
ありがとうございました。
ありがとうございます。
Yes. Yeah, ありがとうございます。